Hello, this is Pure Science Education. Today we will be looking at how to calculate empirical formula. Empirical formula is tested in both GCSE and A Level curriculum. An easy way to do this is to draw a table like I have already done and add in what information has been given to you. So we start with elements, masses. Now, masses can be given in an exam as a grams or as percentage. AR value for the elements that have been given to us. Dividing mass by AR value, which is also known as moles for solid. Dividing by smallest number. And then finally writing the formula. So let's look at what we're doing today. So first example we're going to look at the elements that we got is Mg, magnesium, and O, oxygen. The masses that have been given to us are 0.24 grams and 0.16 grams. The AR value is 24 and 16. If it is A level, then AR value for magnesium is 24.1. If I was to divide these by 24, I get 0.01. And then this side is the same again. So because both sides are 0.01, if you divide it by the same number, you get 1. And same again, 1. That shows that the ratio of magnesium to oxygen is 1:1. So the empirical formula is MgO. So if we was to do a slightly different example, this time we're going to look at 3 different elements. So the first one, this time if we write down the same things, elements. And this time we're going to look at magnesium, sulfur, and oxygen. Masses, they are in percentages, are 23.3%, 30.7%, and 46%. AR value for the elements, magnesium is 24.1, sulfur is 32, and oxygen is 16. If we divide mass by AR value, which is the number of moles, so you got 23.3 divided by 24.1, that gives you 0.9668. so we're not going to round them up yet. If we then do 30.7 divided by 32 gives you 0.959. 46 divided by 16 gives you 2.875. So the next step is to divide by smallest number. So our smallest number is this one here. So if we go 0.9668 divided by 0.959, that gives you 1. If you do the same on this side, 0.959 gives you 1. And finally 2.875 divided by 0.959 gives you 2.99, which is approximately 3. So the ratios is 1, 1 and 3. So the formula becomes MgSO3. So this final time I'm going to show you a slightly different formula of calculating empirical formula, where you have only 2 values given to you. So you calculate the third value, and you also have a multiplication factor that you need to introduce. So this time the elements are carbon, hydrogen and oxygen. The masses in percentage of 47.37, 10.59. Now, because you haven't been given the third mass here, what you need to do is we add these 2 values and take them away from 100, you get 42.04. So in the exam, if they don't give you all 3 and you get 2, just total it up and take away from 100. If you look at the AR value, we've got 12, 1 and 16. We're going to divide mass by AR value. So we got 47.37 divided by 12, 10.59 divided by 1, 42.04 divided by 16, and you get 3.9475, 10.59, and you get 2.6275. I'm not going to round them up yet. The next stage we're going to do is divide by smallest number. So this time our smallest number is this. So if you divide 3.9475 by 2.6275, you get 1.5. The next one, 10.59, 2.6275, you get 4, and obviously the number itself, you get 1. Now, because I have a decimal point, I need to round these numbers up. So what I'm going to do is multiply all of them by 2. So if I do 1.5 times 2, I get 3. 4 times 2 is 8. And 1 times 2 is 2. So to get my empirical formula, I'll end up with C3H8O2. So if you have a decimal point, like I just shown you, multiply by a number, and you can then come up to a whole number, and that's what your empirical formula is. If you have enjoyed this video, please subscribe and click like. Thank you.